So this video is going to take you through practices 1 and 2 from your parametric equations day 1. So question 1 asks, or I guess it says, the position of a particle moving in the xy plane is given by the parametric equation x of t equals 9 minus square root of t, and y of t equals natural log of t plus 5. Where both x of t and y of t are measured in meters and t is measured in seconds. And we're asked to figure out what is the location of the particle at 1 second. So we kind of need to translate what is being asked of us here. So it says, what is the location? We want to know the horizontal location, which is coming from our x of t, and our vertical, which is coming from our y of t. And we want to know that at the specific t value of 1. Okay, so all we need to do is evaluate our horizontal position function, our x of t, at the t value of 1. So we'll take x of 1 and set that equal to 9 minus the square root of 1, which gives us 9 minus 1, or 8. And then we also need to look at our vertical location, right? Our vertical distance. So y of 1 is going to be equal to the natural log of 1 plus 5. And this is a good opportunity to remind ourselves of some properties of logs. Remember, natural log of 1 is just 0. So we have that y of 1 is 0 plus 5, or just 5. So our answer, our location of the particle at t equals 1 is 8,5 meters, meaning our particle has moved 8 meters in the horizontal direction and 5 meters in the vertical direction. Okay, so question 2, parts A, B, and C all ask us to graph the following curves represented by each of the equations. Okay, so we're given a function defining x in terms of t and a function defining y in terms of t, and we're asked to analyze these functions on the domain for t from -2 to +2. So the goal is to take these parametric equations and use them to help us generate xy coordinate points that we can then plot on our graph. So as you saw in the examples, we're going to go ahead and make a table to help us organize our thoughts. So we're going to have a column for our t values, our x of t values, right? Our x equals t plus 2. Our y of t values, where y equals t squared. And then our last column will just be the organization of those outputs into ordered pairs, x comma y. Okay, so the first t value that we have is -2, and that's coming from our domain here, right? Our domain or our restrictions on t. So we're going to plug in -2 to each of these equations. We'll find that x is equal to -2 plus 2, which is just 0. And then y is equal to -2 squared, which is 4. So when t is equal to -2, we have the xy coordinate point of 0, 4. Okay, we'll continue by plugging in our next value of t, which is -1. Doing so into our function that defines x in terms of t, we get an x value of 1, and plugging that into our y function defined in terms of t, we get a y value of +1 as well. So here, when t is equal to -1, we get the coordinate point 1, 1. Okay, and this continues for 0, 1, and 2. And I stop at 2, right? I'm going to remind myself I stop at 2 because that's my upper bound, my upper restriction on my t value. I'll leave the details to you guys plugging in these t-values 0, 1, and 2 into our x and y equation, but you can check and make sure that you agree with me that our remaining points are 2, 0, 3, 1, and 4, 4. Okay, so again, what we've done essentially is we've eliminated the parameter t so that we can go ahead and graph these points on our xy coordinate system over here. So the first point that we're going to go ahead and graph, or plot I should say, is 0, 1. So x is 0, or 0, 4. X is 0, y is 4. Our next point is 1, 1. Our next point, 2, 0, followed by 3, 1, and 4, 4. Okay, just like in the example that we had above, we're not going to say that this parabola continues indefinitely, right? We were bounded on our t values, so we're going to have to stay restricted and bounded here in our x, y points. So we're actually just going to go ahead and connect these 5 points that we have. And the last thing that we need to do is consider the direction in which these were plotted. So when t was smallest, right, our smallest t value gave us this first point. So this is our first point. And as t increased, we plotted points below and to the right of that point 0, 4. So we moved on the curve left to right. Okay, and I'm going to denote that by putting in little arrows that show the direction in which I plotted these points. Okay. All right, so your final answer would include those arrows showing the direction of your curve. Okay, let's go ahead and take a look at B. B, we are given that x is equal to 3 negative 2t and y is equal to 2 plus 3t. And one of the biggest differences here is that there's no restriction or bound on t. So we aren't restricted to just using t values of negative 2 to 2. We can actually use any t values. So just kind of having thought about this problem and looked at it for a little bit, I'm going to choose to go ahead and start my table of values just like I did before, with a t value of negative 2, and then I'll go to negative 1, 0, 1, and 2. And sometimes you might have to play with these t values, right? If for some reason plugging in t of negative 2 gave me an x value of like 100, I would want to make an adjustment because that's not a super helpful point to be able to plot on my graph. Okay, but it turns out that if I use t values of negative 2, negative 1, 0, 1, and 2 here, I'm going to actually be okay when it comes to plotting our xy points. So again, you'll just continue to organize your graph or your table where you have this next column is x equals 3 minus 2t, y equals 2 plus 3t, and then we organize those xy points at the end just to help this graphing go a little bit smoother. So plugging in negative 2 to x equals 3 minus 2 times negative 2, we get 3 minus 2 times negative 2, which will give us 7. Plugging negative 2 into our function of y, we get 2 plus 3 times negative 2, which gives us negative 4. And that results in the point, the xy point 7, negative 4. Okay. Much like before, I'm going to leave the details to plugging in the rest to you guys. I think that's something that you guys can handle, but do check, make sure you agree with these points that when t is equal to -1, we get the xy point 5, -1. When t is 0, we get 3, 2. When t is 1, we get 1, 5. And finally, when t is 2, we get -1, 8. And so kind of linking back to something I was saying earlier, these are all pretty reasonable points to plot on a grid that goes from -8 to +8 on our x-axis and -8 to +8 on our y-axis. Again, if maybe plugging in any of these t values would have resulted in like the point, I don't know, 50, 27, we might want to readjust what we're plugging in for t. But at any rate, we're okay here. So we'll go ahead and take these xy points from the table and plot them on our graph. So we have 7, -4, so 1, 2, 3, 4, we're down here. We have 5, -1, and then we have 3, 2, followed by 1, 5, and lastly -1, 8. So we have our points, and so far this has been a very similar process to what we've seen before. But now, because of this fact that we have no bound on t, we can actually go ahead and extend to infinity on, oops, missed that point, on in either direction of this line, okay? And then we also, again, need to include our arrows, right? We need to show the reader the direction in which we plotted these points. Well, our first point was here at 7, -4. Our second point that we plotted was 5, -1. Our third point here, our fourth point here, our fifth point here. And that's coming from the increase in our values of t, right? As t increases, our points got plotted from right to left. So we want to show that in our graph by drawing arrows in this direction, saying, hey, I plotted 3, 2, and then I came over here and I plotted 1, 5. And then next I came up here and plotted -1, 8. Okay? So that one's a little bit different, but much of that process is still remaining the same. Okay, so part C is our last example for this video. We're again, just like before, going to organize our information into a table that will help us plot our XY coordinates. And here we have a little bit of a different restriction on t, right? Here we're told that t has to be greater than or equal to 0. Okay, so we have to consider t values that are 0 or positive. So let's go ahead and start with 0. So plugging in t, oops, and it looks like I made a mistake in my table. That should not be an x value, but rather that should be a t value, right? We're starting with different values of t and plugging them into our x and y equation. So plugging in t equals 0 here gives us 0. Plugging in t equals 0 here gives us 1. And that gives the point 0, 1. Okay? The next t value I could try is 1. We'll do square root of 1 is equal to 1. And then 1 minus 1 gives us 0, which gives us the point 1, 0. So potentially we could plug in 2. Well, if I have to plug 2 in for t, I'm looking at the square root of 2 as my x-coordinate, which is fine, but graphing the point root 2, 1 minus root 2 is not something that I'm super interested in doing, right? Those are going to be some gross decimals that are going to be really hard to accurately plot. So I think the best strategy, and actually I just realized that that y value isn't actually that bad, right? We'll do 1 minus 2, which will give us -1. But still, having to plot an x-coordinate of square root of 2 is a little bit tedious. So what I would recommend is instead of just jumping to plugging in t equals 2, I might think about what's a good t value to plug in given that I'm going to have to take the square root of it. Okay, I could easily take the square root of 0, easily take the square root of 1. The next number that I can easily take the square root of would be 4. So I'm actually going to choose t equals 4. Plugging that into my x equation, I get the square root of 4 is equal to 2. Plugging that into my y equation, I get 1 minus 4, which is equal to negative 3. And here I'm now looking at plotting the point 2 comma negative 3, which is a little bit easier to manage. Okay, and I'm going to go ahead and grab one more t value. In thinking in terms of nice square roots, I'm going to choose t is 9. That will give me an x coordinate of 3 and a y coordinate of negative 8. So I'll be looking at plotting the point 3 comma negative 8. So we'll go ahead and plot these points on our graph. We'll plot 0 comma 1 first, 1 comma 0 second, 2 comma negative 1, 2, 3, and 3 comma negative 8. Okay, because we had the restriction only on the fact that t had to be greater than 0, we only need to worry about extending in this direction, right? We can't actually extend off here. We don't really know what's happening, and we aren't supposed to worry about that, right? We were told that our smallest value for t was supposed to be 0, so we're gonna mirror that with its corresponding smallest x value, which in this case is also 0, and that's just coming from how x of t was defined. Okay, the last thing that we need to do is go ahead and show the direction of this curve. We know that we plotted 0, 1 first, and then we read left to right to plot 1, 0, and we continued to plot 2, negative 3, and continued on to finally plot 3 comma negative 8. So here, as t increased, our points were plotted left to right. And we have that shown on our graph with those direction arrows.